Hi, everyone. Welcome to my YouTube channel, Maths Made Easy with Terry in 10 minutes. Okay, so we're going to talk about further integration here. And I'm going to talk about the different integration techniques and the rest of it. But before I start, as usual, please make sure you like and subscribe so that you can also get notification when I post new videos, okay? All right, so we're going to start first with the standard integral derivatives. And I'm going to take like 3 or 4 in this video. The next video, I'm going to take about some of trigonometry before we now start integration by part and the rest of it and all those types. Now, let's start first. Assuming you had access to differentiate x raised to the power n, for instance. If I asked you to differentiate it, you would have said x raised to the power n, it would be n, x, n minus 1. Okay? So if you have, for instance, you have 2x cubed, and I ask you to differentiate this, it's going to be 6x squared, right? So this is, I have a playlist and series on this, so you can go back and watch that. Now, but the next part is that, but if you were told to integrate, integration is the opposite of differentiation, and integrate x raised to the power n, that would be what? X. You add 1 to the power and you divide it by the new power. Is that okay? And that will give you, x n plus 1 divided by n plus 1 plus c. That's how you integrate. So if, for instance, we're integrating x raised to the power 7. Okay? We're integrating x raised to the power 7. So apologies for that. Get that out. So integrating x raised to the power 7. Now that will give you x. You add 1 to this, it will be 7 plus 1 divided by 7 plus 1 plus c. Can you see? Now you simplify it further. It will be x raised to the power 8 divided by 8 plus c. And that is the answer. All right. Now the second one is if, for instance, we are told to differentiate let's say ln x, for instance, okay? In respect to x, you would have said the answer, if you differentiate ln x, is 1 over x. Does that make sense? We have talked about that in the previous videos, okay? Now, but the same thing, if you then have to integrate 1 over x, okay? In respect to x, integrate 1 over x, the answer you will get is going to be ln x plus c, okay? It's going to be ln x plus c. So for instance, all right, if we were told to integrate 5 over x, okay? Now, this is the same thing as saying integrating 5 times 1 over x. Can you see? Now, the constant, you bring out the constant, and it's going to be 5. You are integrating 1 over x, and this is going to be 1 integrate 1 over x, like I told you, is going to be ln x. It's going to be 5 ln x plus c. And that's the answer for that. Okay? So basically, what is a standard integral value? You just add 1 divided by the value. If it's 1 over x, when you integrate it, it's going to give you ln x. Number 3, okay? Make space for myself. Number 3, let's say we are having we're differentiating exponential now, okay? So we're differentiating exponential x. In respect to x, okay? It's going to give you exponential x. Does that make sense? The same thing, when you're integrating exponential x, it's going to give you the same thing, and you have equal to exponential x plus c. So if, for instance, we're integrating e raised to the power x, the answer you're going to get is going to be e raised to the power x plus c, and that's the answer for that. So that's if you have an exponential raised to the power x, that's how you get the answer for that. Now let's go to another one. Okay, let's say we're about to integrate or differentiate. Let's start differentiating. If I was differentiating exponential kx, I've done this before in the previous video, and I told you that when you do that, it's going to be k e kx. Do you remember? We've done this in the previous video. Now, but when you integrate, okay, when you're going to integrate e kx, now instead of you integrating the kx and bringing the k, differentiating the kx and bringing the k here, you would differentiate the kx and you divide it by rate. So it will be E kx divided by what? K plus C. Is that okay? So that means you differentiate the kx, the value you get, which is, if you differentiate kx, is going to give you k. You divide the initial question by k plus c. So let's assume we have, we're integrating e raised to the power 5x. Okay? Now, what will that be? You bring out the value back, e raised to the power 5x, differentiate 5x. When you differentiate 5x, what would that give you? 5. It will now be e raised to the power 5x plus c. Okay? Now, we've talked about all the standard derivatives before, okay? So please go back and look at the standard derivatives. That's the first video in the further differentiation series. But when you're integrating, instead of you multiplying it, okay? But in this case, you would divide, okay? That's the two major, the difference here. Then the last one for this time, let's say I told you to differentiate a raised to the power x. Remember in the video, I told you to differentiate a raised to the power x and to give you a raised to the power x ln a. This is what we talked about in the previous video. But what about if we are told to then integrate a raised to the power x? And that will give you, in this case, instead of you to multiply it by ln a, this time you would divide it by what? Ln a plus c. Can you see? And when you're differentiating, you multiply the a raised to the power x by ln a, but in integrating is the opposite. So in this case, you're going to divide it by ln a. So for instance, if we're integrating 5 raised to the power x, is that okay? So if we're to differentiate this, it's going to be 5 raised to the power x ln 5. But because we're integrating, it's going to be 5 raised to the power x divided by ln 5 plus c, and that will be the set of the standard derivatives. So, just a quick recap for this video. The first thing, when you're integrating x raised to the power n, okay, when you're integrating x raised to the power n, what do? You when you're integrating x raised to the power n, you add 1 and divide by the new power plus c. So that's why we have x raised to the power 7 is going to be 7 plus 1 divided by 7 plus 1, and that will give x raised to the power 8 divided by 8 plus c. Now, when you're integrating 1 over x, okay? Once you get 1 over x, it's going to give you ln x plus c, okay? So if you have something like integrating 5 over x, you take the 5 out, and you leave will be 5 integral of 1 over x dx. And when you differentiate this, it's going to give you 5 ln x plus c, okay? Now, when you integrate an exponential, it will still give you that same exponential plus c. Is that okay? For the exponential with a constant in the power, what you do, you differentiate the kx, you get a value, and you now divide it by the original exponential question. So, for instance, you have 5x. When you differentiate 5x, it's going to give you what? 5. Okay, it's going to give you 5. So 5 divided by e raised to the power 5x divided by 5 plus c. Now, e raised to the power x, the same thing. If you are differentiating, you multiply it by ln a. But in this case, you are not differentiating. Here, you are integrating. So in this case, you're going to divide it by what? Ln a. Okay, you now divide it by ln a. So in this example, you're integrating 5 raised to the power x, it's going to give you 5 raised to the power x divided by ln 5 plus c. Okay. I hope you understood what we said. Please don't hesitate to go back, look at the videos again, watch it and understand it. In the next section, I'll be talking about trigonometry. Is that okay? I'm talking about trigonometry, and I'll be talking about how to integrate trigonometry function like cos x, sin x, and the rest of it. All right? Please, if you have any question, feel free to put it in the comment section, and I will get back to you. Thank you very much. Okay, that is that for that.